All right, welcome to my video on the construction of my Daft Punk Guy manual helmet. I have another video that explains what's inside this control box, and check the links below for the instructable on how the helmet was actually constructed with numerous photos on that build process. Let's get into it. The gloves were very easily done by 3D printing all of these segments on PLA filament. They're about a 1/16 of an inch thick, and they were very quickly processed with sanding, a little bit of Bondo, and sand some the Bondo, and then hit it with Rust-Oleum Auto primer that's sandable, and then finish coats of gloss white Rust-Oleum. Could have really got into this. You can see some of the print lines on this, but hey, they're gloves, you know. I didn't want to spend a whole lot of time on doing that. They look good enough. They're affixed to these spandex glove liners with fabric glue. The only thing I'll say about that is when you go to the fabric store to get the fabric glue, talk to them, show them the pieces that you want to fix, because some fabric glues are better than others for bonding heavy stuff to fabric, and this is one of the better glues that they have for that purpose, and these are really secure on there, whereas other fabric glues, this will easily peel off. So make sure you get the right fabric glue for that. So that's how I did those. The control box is printed on PLA filament. I did not do any real work on sanding it or try to get smooth out the lines because this is clipped to your belt, and it's inconspicuous below your suit coat. So there's no reason to spend a whole lot of time trying to make it that pretty. If you wanna, okay, great, go for it. But I just needed a box to house the Arduinos and the battery pack. The only thing I will say about the box is when I designed it, I put a solid belt loop so that you have to thread your belt through it. I did not want to clip so that it would maybe strain here and break, and I didn't want to risk having this get lifted off and then falling to the floor. So your belt goes through this, so you have a positive capture of this control box when you're wearing it. The wires are solid wire. There's quite a few wires here. There's something in the neighborhood of 18 wires in here. These are solid 22 gauge wires. I thought about using a ribbon cable here, but ribbon cable was just too much of a pain to try to strip that all out. I could have bought individual stranded wire, but then again, you have to tin it, and then to solder it to a circuit board, and to make contacts with Arduino pins and all that. I just went with solid. I think it's going to be fine. I did put a real nice strain relief on there and some braided sleeve to protect it, and I don't see a whole lot of movement going on back and forth, back and forth. Once you're wearing it, the cable will just go up and into the helmet, and it should be fine. If it does break, then maybe that's when I'll redo it with stranded wire. I just think solid wire is easier to work with in the build process. The helmet, the tough one with the helmet was thermoforming the visor. This is PETG at 0.060 or 60 thousandths of an inch thick. I bought this in a 4x8 foot sheet for around $70. I cut it into 24 by 24 inch squares, and then so I got 8 squares of this for $70, so a little bit less than $10 a sheet. And it took me 3 sheets in my oven to figure out. I built a custom oven and a thermoforming rig to thermoform this over the visor buck, and it took 3 sheets to get it right, and then so I got five visors out of it, and I dyed it with the iDye product for polyester. So it's a real good dye. So the brand name is iDye, and you have to heat the water to like 140 degrees Fahrenheit. Follow the directions carefully. And it took 3 cycles of dyeing and rinsing, dyeing and rinsing, dyeing and rinsing, about 15 to 20 minutes each cycle. You can always dye it darker than leaving it in there for like an hour and then pulling it out and then say you can't see through it. So take your time on that. I know people are gonna probably ask me, what temperature did you heat the PTEG up to before you thermoformed it? I honestly can't remember what it was. I want to say it was in the neighborhood of 170 degrees Fahrenheit, but it's a very narrow window of getting it too cold or too hot, and you pretty much have to work quickly once it's at temperature. Too cold and it won't stretch, too hot and it's almost too loose and you'll get webbing or wrinkles when you thermoform it. So you're going to have to test it based on your oven setup and how strong of a vacuum your thermoformer will vacuum it down at. So it's more of an art than it is a science. So hopefully I'll do an instructable on my thermoformer, and there's more instructions on that, but there's a lot of information on the internet for thermoforming. It's just practice makes perfect. So make sure you got enough sheets so that you can get one that really forms well with no distortions or webbing. The helmet is made out of ABS, and it was printed in an enclosure that was quite hot. The ambient temperature was quite hot, yet I still got shrinkage cracks here and here and here and here where it was contracting and it split along the layer lines. The layer lines, it built up like this, and this was laying on the bed, and I was seeing those develop, and I just thought, just let the helmet go in and let it all shrink and contract and let it cool down and see where it ends up. And so I had a pretty nasty crack here that was you could easily see that it was going about this far into the helmet. This was another good one. These were real minor, but when you flexed the helmet, you could see how far it was going in. So I opened up the crack with a soldering iron, and then I added more ABS with a 3D pen and filled in the crack. But with a 3D pen, filament pen, even though it's ABS, trying to bond to ABS, you still get a cold joint, and you don't get a lot of heat penetration when you do that. And if you've ever used that, you can take your knife or your thumbnail and you can almost break that filament away from the base helmet. I just used it to get ABS in there, and again I used a soldering iron to smooth it out as best as I could. And then what I did to take the stress off of these corners was on the inside, I took copper wire, a 14 gauge copper wire used for house wiring, and I stripped off the insulation, so I have a bare copper wire in here that I heated up with a propane torch. With a needle nose pliers, once it was hot, I pressed it in from the inside, so I have a wire that's in the center of this helmet right here, and I got a piece of copper wire in here, and I got a piece of copper wire in here because I was starting to see little cracks in here. So I wanted this area really, really strong. Once I pushed that in there, I followed it up with 2-part epoxy Bondo, the pink stuff, and then I sanded it smooth, and this is like super strong. So when you flex it, you can't even flex this right now. It is really, really strong. So I did that on both sides. And then I went through the standard finishing techniques for the helmet. You sand it, you add some Bondo, some spot putty, you sand it down again, you hit it with a auto primer, the filling sandable auto primer, and then you see where the imperfections are, you spot putty it again. You do that like 3 times, and then you smooth it all out, and then you're ready to go. When the primer looks good, then I followed it up with Rust-Oleum gloss white. I went with the gloss white because I think it looks it's of the Grammy Award helmet, and I think it's easier to like touch up then if you should get a nick. You can spend a lot of money chroming these helmets and maybe not quite get the finish you want, And so I figured I wanted something that I could maintain very easily and still have a classy look to it. And I honestly like the white and the dark black of the visor. So I'll show you the inside of this very quickly. This was a little stand I made just to kind of keep the strain off of the wire. 3/4 inch conduit, printed that and just painted it. So here is the inside. I want to show you where the cable comes in to a D-shell connectors. This is epoxy glue. The female connector is epoxy glued inside the helmet. This male connector comes up and it's secured in place with these 2 screws with these tabs that I made out of some copper sheet metal that I had. And the microphone for the VU meter is right here. I did have a error. I could have brought this up a little bit farther, and I forgot about the thickness of this joint, but I figured it's in the back. I'll just go with it. I probably should have redone that, but I got lazy, I guess. Now on the inside, the wires, there's like 18 wires that are coming in here. And so I secure the wires down to the helmet with black duct tape, 3M quality duct tape, so it really holds. I painted the inside flat black, and I put a couple of pads in here, some thin foam to just make the helmet more comfortable. What you're seeing in here is painter's tape just to keep the visor from getting scratched, and you can see the brackets that are holding the addressable LEDs for the rainbow effect, and the cable and the wiring that goes into that. So it's a very tight helmet. If I were to do this all over again, I would probably print the helmet at maybe 105% just to get a little bit more room in there and put in more pads, but it works. So so that's how it comes together. The visor is held in place with T-nuts. Let me show the inside again. So I got a machine screw, a 632 machine screw coming through the bracket. It goes through a hole on the visor and it goes into a T-nut that's epoxied to the inside of the helmet. And that's what holds the LEDs and the visor sandwiched in between there. And I have a bicycle pad right at the top for comfort. So let me show the sequence here of what this thing does when it's all powered up. As I mentioned, the box has the 2 powers. It's a single battery pack with 2 batteries. So this button selects A or the B side of the battery. There's a 10,000 milliamp hour battery. It's 5,000 for each one of the batteries, so you can get a lot of time off of this. If you're wearing it for several hours, there's more than enough storage here. So I went with that, so that when one battery dies, you can just hit this button and then go into another, the other battery, and it should work. Okay, so now I powered it up. The LED tells you that it's powered on, so you can tell that you should be seeing something here. In the video, you can probably see a little bit of the LED strips, but the camera's more sensitive to light than our human eyes, so I can tell you that I'm just seeing the LED lights. I'm not seeing the bracketry or anything inside here. Especially at night, it's even better with that because the light just blows through and you can't see in. So I have one Arduino that's controlling the ear pulses with the white scanner bar that's underneath here. I don't know if you can see that white scanner bar, but this is what Daft Punk has. And they have so one Arduino is controlling the ear and the white scanner. Another Arduino is controlling the VU meter from the microphone that's picking up sounds here from the back. These will change color and their intensity. So when there's music playing, you can really see this a whole lot better. It's fairly sensitive right now, but it'll change color as the volume goes up. And the rainbow display is going through a number of sequences that it'll just keep cycling through. So I originally thought about having buttons in here to select what sequence you want to display, but when I talked to my son who I built this for, he said, no, just have it step through the different patterns, and that would be kind of cool. So right now it's just it's going. Now there's the confetti. This is the last display. This is just a random array of like sparkles, you know, for the array. The array is 56 pixels big. So there's eight bars, eight groups, and there's 7 LEDs in each one of those groups, and now it's just randomly lighting those up. And then it's going to start the sequence all over again. This is the end sequence. So I had to put that on its own Arduino because it was taking so much processing time to go through all of that. The VU meter wasn't working right. The earbuds weren't working right. So I had to break it up over 3 Arduinos to make that work. At least that's how I did it. These are all addressable LEDs, except these are conventional LEDs right here. So now the sequence is going to start all over again. And this is just this rolling stack of the rainbow stack. So you got Roy G. Biv just rolling up. So it does that, I believe, 3 times or 2 times. And then it does that look. So this is what it looks like from the front. It's kind of got a pretty cool look when it's fully lit. And so that's the what I call the rainbow stack. Now it's just stepping through the colors one at a time. I call that the wiper mode. So it's just wiping through the Roy G. Biv. Now this is like a snake pattern, and so it snakes through, and you can see it changing colors as the colors are snaking through. So it goes down, and then it snakes back this way, and then it'll snake back that way. So that's another routine I got in there, and then. It's going to go through it always goes through all the colors, Roy G. Biv, red, orange, yellow, green, blue, indigo, violet. So now this is just like a scissors look. So it's stepping through the colors now. There's green, and there's like a yellowish, and so it's just doing through the scissors. And then now it's like a reverse scissors. It's coming together from top and bottom, stepping through that. And I think we go to confetti if memory serves me right. Yeah, so then that's the last routine. So that's how it works. I hope you like it, and I hope I've encouraged you to maybe try the project. It took several weeks to build it, but I thought of it as individual projects. You get this working first, then you get this working, then thermal forming was another project, then building the helmet was a project. And it took 3 days to build the helmet. I printed it kind of at a low layer rate, so when the helmet's printing, you can go work on something else. So I hope you like it, and we'll see you next time.